Wait, I hear there's a problem with the sound. Let me just test again. Vlado, can you try unmuting yourself? You are on mute now. Yeah. Yeah.
Okay. Sorry about it. Okay, so this is the outline of the webinar. Unfortunately, I'll have to go somewhat quickly in order to cover all of these topics. Now, let's start with a few words about Ontotext. So it was founded in 2000 as a research lab within Sirma. Sirma Group Holding is the largest Bulgarian software house, private Bulgarian, but now listed on the Bulgarian Stock Exchange since 2011. In Ontotext, we have 65 people. Most of our developers are in Bulgaria, although we have a couple of consulting developers also in the UK, in New Zealand, and we have sales representatives in Canada, UK, in Germany, and the US. We have worked with a number of important clients that you see on the next page, and we also have won a number of R&D awards for our software. And we are members of relevant industry bodies working in semantic technologies. For example, W3C, I guess everybody knows. These are the people that develop the web and the semantic web. EDMCR developers the FIBO, Financial Industry Business Ontology. ODI is the Open Data Institute in the UK, promoting the use of open data, and so on and so forth. Now, this is a selection of our clients. Quite a lot of them are in the media and publishing sector, semantic publishing for scientific articles, engineering, life science, and so on. Also, life science and pharmaceutical companies. A number of companies or institutions in the cultural heritage domain, like the British Museum, for example. GraphDB is the semantic database that Ontotext develops. It is built on top of RDF4J, which is one of the two most popular APIs for working with RDF in Java. We're also the largest contributor to the RDF4J project as a commercial company. GraphDB complies with all of the relevant W3C standards for RDF and inferencing and Sparkle querying and so on and so forth. And now I'll just say a few words about the group that I work for, which is called Innovation and Consulting. And basically we work in, I guess, 4 areas. One is semantic integration, which includes semantic modeling, ontology engineering, transformations, conversion languages, and so on and so forth. Second, we experiment with tools and integrate various tools. Third, we work on a number of research projects. Here you can see our timeline of projects. At any given time, we have between 4 and 7 under execution. And fourth, we also consult with clients. Now, this webinar itself will cover editing of Sparkle within GraphDB Workbench and the tools that you can use to help you with this editing, how you can invoke queries written by others and pass parameters into these queries, data visualizations that are built into GraphDB and others that can be added with just a bit of programming. Another topic is third-party tools that can help you with constructing Sparkle, and third-party tools for developing visualizations for which some amount of integration work would be required. This webinar will be provided as a recording. Also, the presentation is available online, but there's also a full report, which is the basis of this presentation. I'll just show you the published version of the report. It's about 30 pages and has more details than in the presentation itself, but it covers pretty much the same material. Okay, the first topic that we're going to cover is writing Sparkle in the GraphDB Workbench. The Workbench integrates the very nice Yas GUI editor, and through this editor we have three features that are quite useful when writing queries. First one is automatic insertion of prefixes. So if you type PDM, in this case, this is the Rupana data model, and assuming that you have loaded at least 1/3 of file to define this prefix, when you type PDM colon, if this prefix is not yet in the query, the editor adds it automatically. This is the first line here. The second feature is auto-completion of class names. So here we're in a position and it lists all of the classes that it knows in DDM ontology, and you can select one. Similarly, we have property between people and allowing others to develop demo queries and then saving them. So FactForge, the site is factforge.net. It's on this link. This is an aggregation of a bunch of open data sets which are to some extent interconnected. For example, you have their geonames, you have DBpedia, linked leaks, which is an RDF representation that we did of the Panama Leaks dataset. And in this case, if you go to this link, it will load up the saved query F04, which lists industries by the number of companies that have declared that they work in this industry. So the way that you can see the saved queries is by this here icon. Okay, the next topic is using the built-in visualizations in Workbench. So after you select this query and run it, first you see a table of the results, but then if you switch to the tab Google Chart and click Chart Config, then you can select an appropriate chart to visualize this result. In this case, I have selected the bar chart and tweaked a bit how to display the axis and whether to rotate the text and so on. The full complement of Google Charts is available there, including bar charts, geocharts that show things on top of a map of the world and so on. There is, in addition, these pivot table charts. So if you have 2 or 3-dimensional data, you can use those to interactively put select which should be the X dimension, which should be the Y dimension, and so on. So this is typical OLAP stuff. But I'll have more about this when we talk about visualizing statistical data. The next topic is how can you use results in other tools, in this case in spreadsheets, to do your own analysis. So here is the same data, industries and the number of companies declared in each industry. And this is a live Google Sheet that you can explore, how this data is processed and how the chart is created on top of the data. But basically, we have one formula here to fetch the data in these two columns, and the second formula in this column to extract just the industry name from the industry URL. The two formulas look like this. So first is import data, which says go to this URL and fetch the results there in CSV format and put it in two columns. On the next slide, you see how we can find out this big and ugly URL. This URL represents the complete query. And the formula in the third column is just replaced by regular expressions. So we're saying cut out the prefix up to and including resource slash, replace it with an empty string to extract, as you see here, from the URL, extract the industry name. Okay, so how can you invoke a query that was constructed by you or by somebody else by URL, and how can you pass parameters into that query. First is how to find the URL of a query. Well, in the Sparkle editor, there is a button looking like a link, and when you click it, you get the query URL. But you also need to understand the difference between the interactive endpoint that lets you write Sparkle versus the programmatic endpoint that lets you execute this Sparkle and return the results in a machine readable way without the UI. Okay, so there are details in the report about how you can use this REST API to find the list of repositories under this server, and from there the Sparkle endpoint for the selected repository. In this case, this is FactForge plus a bit of information that comes from news articles. The results from this endpoint are in CSV format. If you want them in tab separated, then you also need to provide an accept header when you make the HTTP request. So with curl, you add an option like this, -H, and then you specify the accept header. Okay, now this here query, the intent is that I want to find all the industries for a particular company. Dollar and question mark mean exactly the same in Sparkle. They designate a variable in the query, but by convention, dollar is used to indicate a parameter, so something that will be substituted in the query from something else, from the outside, whereas question is used for a free variable. So the intent of this query is that we'll replace dollar company with a particular URL, and we want to get all the industries that this company is related to. You have to format the value of dollar company as a data point in N-triples format. So for URLs, you have to use this full format with angle brackets. If you want to pass a string, you need to put it in quotes. If you want to pass a string with a language tag, you format it like this and so on. And then you add to the HTTP GET, you add a parameter like this, dollar company, corresponding to the variable that we used. Okay, so if you try this link, which encodes this whole query together with this parameter, it is going to return the 4 industries that DBpedia knows about Google. Okay, next up is a number of third-party tools that help people who are not conversant with Sparkle to make queries against an RDF database. First is a tool by the French IRISA laboratory called Squall, and the links here are a few papers about it and a live demo with a few examples. So you see that you can ask a question like this, which is almost English, but this is controlled natural language. What does that mean? Well, you cannot ask it a random question. It has to be a question in a particular domain that corresponds to the ontology that has been loaded in the tool. Okay? But you see that the question is asked pretty much in English. You only have to, because there is a class called publication, but the tool doesn't handle plurals, so you have to write it like this to let it recognize the class. And this question is translated to this query, which is actually quite adequate and fairly efficient to answer this question. So we're looking for all of the publications of X3 is a publication, so this is the class, and give me the author into X1, but then count the distinct publications. And so we're looking for publications for authors that have at least 10 publications. Okay, the next tool is by the same author, by the same researcher in IRISA. It's called Sparklies. And Sparklies is one of the most useful tools that I have stumbled upon. it allows you to explore the data. So you see here classes, for example, and then number of classes, and also connections of these classes, number of instances. So it's kind of like a faceted browsing interface for RDF, which allows you to write Sparkle queries that are going to have answers. It helps you by showing you what data matches what you have already written. And all of these links here, there's a very nice video demonstrating how the tool works. There is a demo setup and so on. The next tool is called Grammatical Framework, and the way that we used it in the MOTO research project, MOTO stands for Multilingual Translation. A distinguishing feature of Grammatical Framework is that it supports multiple languages. By first developing an abstract grammar for a domain. What is an abstract grammar? Well, you define in a language neutral way the kind of questions or statements that you can make. And after that, you also tie it up with surface grammars. The Grammatical Framework comes with a number of NLP resources for different languages, so you don't really need to be a professional linguist in Dutch, for example, to add Dutch to your application. You can use those existing resources. If one of the surface languages is Sparkle, then you can use this route from English, but of course this is controlled English. It cannot parse a random question in English. It has to conform to the abstract grammar. And then it parses the English, creates an abstract grammar representation, and from it can generate a Sparkle representation. In the MOTO project, Ontotext used this in the museum domain. So here you see a question about paintings that fixes the type of painting and the location where it is exhibited. And you can ask it in English or in Swedish or in any of the other languages that were on the previous slide, and this is the generated query. We also used it in the other direction, from RDF data to natural language, or what is called lexicalization. In other words, generate NLP descriptions of objects in the RDF database. So you see here a dozen sentences in different languages about the same painting. It's not perfect. You see that the label of the painting is not translated. So in this case, the label was only available in English and in Finnish and in Hebrew. And when it has a label in a particular language, it puts it in the sentence, but for all the rest, it uses just English as a fallback. Grammatical Framework cannot handle the title because this is not in a controlled language, right? The title of a painting could be anything. But we could call out into an online translation service like Google Translate, for example. Now the rest is generated. So this is a fairly good Bulgarian sentence. If you look at the Russian, this here word is not very well. It should be был нарисован, not нарисовался. But it's understandable. There are, I think, 4 more tools in the full report if this topic is interesting for you. Okay, the next topic is statistical data. There is a very well established ontology for representing statistical data in RDF. It's called the Data Cube ontology, or QB. And it covers typical things that you can find in OLAP. So a multidimensional cube of observations, and every observation has measures, dimensions, and the observation, the number itself. It also complies with SDMX, which is a way of organizing these dimensions in a hierarchical way and using well-established terms for things like age, population, various other statistical indicators, and so on. There is a whole bunch of statistical data freely available as RDF. I have listed the number here. Probably the biggest set is this linked SDMX data. So it has the European Central Bank, World Bank, the Organization for Economic Cooperation, the Food and Agriculture Organization, Statistical Bureau of Switzerland, Transparency International, and so on. Unfortunately, I think this data is static, so it was converted a few years ago and I don't think it has been updated. There's also a couple of wrappers which provide live data for Eurostat and for the US Securities and Exchange Commission. In the multi-sensor research project, we have also provided some statistical data from the United Nations Comtrade, and this is trade statistics between countries. Okay, the first tool for visualizing W3C cube is by the Leipzig AKSW laboratory. It's called CubeVis. The original project was developed in PHP and it had dependency on another AKSW tool called Ontotext. And this is currently being rewritten to JavaScript to run standalone. This JavaScript redevelopment is in active development, so we can expect soon a lot more charts and so on. This shot is from the JavaScript version. This is from the PHP version. It was used on the European Open Data Portal. So this here is a polar chart showing the progress of the European Union along its digital agenda guidelines and roadmaps. Then there was a separate European project called OpenCube to develop more tools for data cube visualization and generation of such RDF data. It developed a bunch of tools in 3 categories. First, for creating RDF data from tabular, from relational data, and so on. Secondly, for finding cubes that are compatible with the cube that you have locally and getting data from the open web and complementing your cube with extra data, and also expanding cubes along dimensions. For example, to create a bunch of subsidiary cubes of lower dimension out of a cube that you have of high dimension. There's also a number of exploration or data visualization tools, including this one for making charts and so on, this one for making pivots and drill downs and roll-ups, this one for slicing and dicing, this one is for visualizing statistical data that has a geographical dimension. Unfortunately, there is no currently available demo of these tools, but all of them are on GitHub, so they can be taken up and revived and so on. Now, this tool, Cubes Viewer, unfortunately does not yet support RDF data, and I have made on GitHub an issue to see whether other people are interested to maybe collaboratively develop an adapter for W3C Cube. This project, Cubes Viewer, which is a front end for making visualizations, is based on this Cubes framework for adapting and reaching out into several different OLAP data stores. So basically, it would be interesting to develop an RDF adapter for cubes. As you can see, Cubes Viewer can generate a whole bunch of interesting charts. This is very typical in statistics, for example. This is a breakdown of a population by age. On the left side is female, on the right side is male. Interesting, powerful things like this, which are not available, or I'm not sure are very well developed in the RDF tools that I showed earlier. Okay, the next topic is graph visualizations. So everything that I showed until now was visualizing data of tabular nature or multidimensional nature. But RDF, being a graph data model, is also interesting to explore the graph nature of that data. What is connected to what else? I'll start with 4 charts that are built into GraphDB Workbench. So it's this class hierarchy, class relationships, and visual graph. Class relationships shows the number of instances that you have per class here on the circle. So in FactForge, the biggest number is classes of type GeoNames feature. GeoNames has over 10 million different places, and this here brights show you the number of relations that this class has to different other classes, and also the numbers are broken down here. Next one is the class hierarchy diagram. So this shows you number of instances, and the nesting shows the class hierarchy. Currently we have selected the class agent, which is over here, and it has subclasses such as organization and person. Now you may notice that the selected class comes from the DBPD ontology, but it shows two subclasses in the schema.org ontology. How come? Well, the answer is that we have also loaded an alignment file that says that DBO agent is the same as schema agent. So it shows here schema organization, but actually this is the same as DB organization. If you click on this circle, schema person, it will show you a breakdown of this class by its different subclasses such as sportsman, artist, and so on and so forth. And here we can see that we have 2.9 million instances of agent and the sampling of this, and these happen to be high schools and colleges and so on. There's also a domain and range graph which shows you for a selected class what are typical properties that come into this class and that go out of the class. So for example, this here art patron says that an agent, person or organization could be a sponsor or patron of a DBO artist. Now, those showed you an overview of the ontology and number of instances in an ontology. But if you are interested in one particular resource, then you can also look at the connections of this resource. In this case, this comes from the linked leaks dataset that we created out of the Panama leaks of the International Council of Investigative Journalism. Those guys won the Pulitzer a few months ago for this work, which was 1 year ago. So if you're an investigative journalist, you definitely need to know about these data sets, and hopefully you can use them in your work. In this case, this offshore entity, which is called, used to be called Trinity Financial Group Limited, now it is called Deo Capital Group Limited, and it is situated in the Mauritius. No, actually, this is where it operates, in the Mauritius, and the jurisdiction is the British Virgin Islands. So we also have a bunch of visualizations of companies from which countries register offshore entities in which other offshore locations and so on. Or in this case, we've selected Google in the center, and the rest, the data comes from DBpedia. So for example, we can see that YouTube is a subsidiary of Google, and also Vevo is a subsidiary of Google. In the opposite direction, there are 3 links from Vevo to Google. They're not shown here, not to overload the diagram, but if you click on here, you'll see which 3 they are. Now, all of those were built-in visualizations that any end user can see. But with a bit of programming, you can do a lot more powerful things. So on the GraphDB Developer Hub, there is a topic visualizing RDF data with this library. The developers of this library, Linkurious, they are also providing the visualizations in the Panama leaks. So they have worked hard to develop developer-friendly toolkits to generate stuff like this. In this case, we see a bunch of companies and their connections. So for example, we see that Elsevier which is the type of this node, green, is company. It is controlling a bunch of publishers like Medicine Publishing, Churchill, Livingstone, and so on and so forth. And here, for example, well, Synergy Group, which I guess is a big holding, controls Avianca Holdings, which controls Aerovias, which is an airline in Brazil. But this here thing also has some connection to Panama, so there's probably some offshore connection there. Or in this case, we are visualizing flight paths. So some person, as you see, took quite a trip from South America over to Spain in Barajas and then over to Sofia. Okay, the next topic will be various toolkits that could also be used to visualize RDF data, but this will take some integration effort. D3 is quite heavily used by developers because it fully leverages the features of modern browsers such as SVG visualization and styling using CSS. Tableau is a very powerful end-user tool, and I will have some screenshots from our own data using Tableau as well as Microsoft Power BI. Go.js is also a very nice library of charts of various kinds for JavaScript. Google Charts you already saw, they are integrated in GraphDB Workbench. Linkurious you can integrate with a bit of development effort, and we have examples for this. And there's also a huge amount of tools that are specialized in various things. Histopedia, for example, is very nice. They have a bunch of pretty timelines constructed from Wikidata, and we would love, for example, to deploy Histopedia on your own data. Here is an example with Tableau. So this was developed by our friends from Pansoft and a few other guys in a datathon and a hackathon that was held in Sofia in May and June. This is public procurement, and the size of the circle shows the amount of money that was spent, and they are clustered by the last 5 Bulgarian governments. So this is the Boyko Borisov government, I guess about 8 years ago, and this is the current government of Boyko Borisov. Next up is another visualization done with Microsoft Power BI. So you see it's relatively easy to get data out of RDF stores and then use these stock well-established and well-known visualization toolkits. Okay, the next topic is a bit abstract maybe, but I think it's quite interesting and important. Can you develop visualizations by describing them in RDF in a declarative way, rather than having to write programs or tweak things in an interactive way? Is it possible to just generate charts out of RDF? And we have 1 or 2 tools for this. So for example, this here is a semantic mapping. It shows how we laid out some Dun & Bradstreet company data to the FIBO ontology. And even though you cannot read this, when you zoom deep enough, you can see it. I'll only show you these here 3 nodes. So this is information about the annual sales of the company, what is the total net worth, and what is the profit and loss for the current year. And this is a very detailed way of describing how semantic data is laid out. And so it is quite useful to be able to generate this automatically without manual tweaking, and also to be precise. This corresponds exactly to the semantic model, and furthermore we can generate data conversions, R2RML conversions out of this. This is an example of generating R2RML conversions. So this is some model of exhibitions in the museum domain, and because we have relational joins embedded here, and we also have here in brackets the particular fields that should be used in this property, or the particular field that should be used to create the URL. Then when we run the R2RML generator, it expands that to a much bigger thing in R2RML. So this saves quite a lot of effort, this generator. This is one small detail from that diagram. So this one node in the semantic model gets expanded to 15 nodes, and on the next slide you see just 3 or 4 of them, which describe in a lot of detail what should be the predicate to use for this one node, and what should be the URL of the object, and so on and so forth. Okay, and the final topic is whether it's possible to kind of automate the feeding of RDF data into those visualization tools like Tableau and so on and so forth. So JDBC, that stands for Java Database Connectivity. It was one of the earliest Java standards. It's modeled after an older standard called Open Database Connectivity. ODBC is the way to access various types of databases and Excel on Microsoft platforms, and JDBC is a way of accessing the same relational or tabular data sources from Java. And quite a lot of the visualization tools like Pentaho and Tableau and ClickView and so on, they have ODBC and or JDBC interfaces. So the idea here is that there exist a number of open source implementations of JDBC towards a relational data, towards a Sparkle data store. One of them is for Jena. So RDF stores that implement the Jena API by using this component can be exposed as JDBC. And we're thinking of re-implementing this or porting it to RDF4J, so it can natively work with our semantic database. Then the user would still write Sparkle queries, not SQL queries, but these queries will be passed through JDBC to the database. The results from that database will be converted automatically to a JDBC dataset, and they can be passed back automatically to the visualization. Okay, and that's about it. Now we can spend a few minutes to tell you a bit more about the training. This training is also organized by our group, Innovation and Consulting. I think it is the 4th or 5th time that we run it. We get quite good feedback about it. It includes 1 hour of free individual consultation with every participant, and the price is really quite low. So it is intended for people who already have a specific problem to resolve. They've already played with RDF and have some experience, and now they want to try and use our graph database and develop their project further. Okay, we'd love to talk to you about deploying some of these tools that I showed for your particular data set or your particular problem. You can download GraphDB. We have a free edition which has all of the features of the paid editions, except you can only run 2 simultaneous queries to it. And we'd love to help you in your exploration of RDF and semantic web. Now we'll be happy to see what questions have accumulated.
So I don't see any questions, and I wanted to apologize. Oh wait, there's some really nice comments. Okay, we just have Evelina, who's joining us here. She was a little late, but that's okay. And we finished earlier. Who can tell us a little bit more about the training that's coming up? I just wanted to ask her, so the training is about designing a semantic technology proof of concept, and I wanted to ask you, Evelina, who's the leading instructor and also like Ontotext leading NLP engineer, to tell us a bit about what people can expect from the training, what they can learn and gain by joining.
Hello. So during this training, you will be gaining skills for working with GraphDB. You will be able to load, clean, and modify your data, even it's not RDF data, but some other form, in some other format. You will learn how to transform it to RDF and being able to run Sparkle queries against it. You will also do some advanced Sparkle in order to make you feel comfortable querying the data store. Also, you will be able to try yourself the visualizations through the GraphDB workbench and do hands-on with an application which is built on top of GraphDB, so proof of concept.
Okay, and referring back to what Vlado said and was explaining for the last an hour, are you going to show people how to make data visualizations from RDF datasets? Is there a component like this in the training?
Yeah, sure. So we are doing this first in the GraphDB workbench from the data which is loaded for the exercises, and then also we are showing various visualization scenarios from the proof of concept project that we are demonstrating during the training.
Okay, and another quick question before we go back to the questions for the webinar. How are people going to interact, let's say, and manipulate data? Is it going to be like you show them how to do stuff, or so would they need to be using GraphDB or any other tools?
Yeah, sure. Our goal is that everybody touches GraphDB themselves and try everything we explain. So there is both a session where we explain how it could be utilized, but also a session where the participants do the exercises themselves in the hands-on session, and we upload the data in advance so everybody can have it handy during the training. Also we expect that everybody has GraphDB installed locally on their machines. Apart from that, during this training, we're also going to show how one can use GraphDB on the cloud.
Okay, great. Just to make it clear, the whole training, how is it set up exactly? There's a live session, obviously. Something else?
Yeah, well, we start with the materials, which everybody receives 1 week earlier, and could do their self-paced training. And then we have live session which continues for approximately 5 hours, where we do sessions of explanations and hands-on, and finally we complete with the proof of concept project built on top of GraphDB. And of course the Q&A sessions where everybody gets to know more.
Too bad it's not live. I mean, it's not.
It's not
it is live, but it's not like physically live, so people can have pizzas in the break. Okay, so we do have a couple of questions, as I see, and I'm gonna hand over to Vladimir to answer them. Go ahead, Vlado.
Okay, the first question, whether the slides are available. Yes, both the slides and the full report, as you can see here. The links will be provided on the webinar page where you registered, together with the recording of the webinar. Okay, the second question is about Linkurious, how easy it was to use Linkurious. Well, as I mentioned, there is a link on the GraphDB Developer Hub, and this is the first query about connections between the connections of Google, people and organizations that are connected to Google. As you see, the query is a bit complex, but that is to be expected, right? And then the part with invoking link queries, I think it's not too big. I think it's quite okay. It's not so complex. Let's just see it, flight shortest path. So in this visualization with the flights, and let me show it again. We have a whole bunch of flight paths that are recorded, and we're looking for a shortest path amongst them. So again, here's the query, and then this is the part that works with link queries. This is a bit bigger than before. Okay. Next question: which is the easiest visualization tool that I would recommend? One that is easy to use, straightforward, and does require the minimal effort. Well, there's no single answer to this because it really depends on the complexity of visualization that you need to provide, and also whether you need your end users to be able to select and tweak things. If it is something that's already done, of course, it is much easier because you just matter of configuring it or reusing a UI that your end users can also use to configure it. If it is something for which you have an example, I think one of the best features of D3, for example, is that there is a whole lot of visualization provided by the creator, and you can use that as template code and within a very short period of time develop your own visualization. It really, the balance is between whether you're a programmer, what language you are experienced with, or whether you need to use a totally end-user tool like Tableau, for example. Tableau is very powerful, provides a whole lot of different things. For example, these clustered bubbles along a timeline and color it in a particular way, and the size is a particular thing. I haven't seen it in other visualizations. Okay, if there are no other questions, then I think we're done with this webinar. Thanks for attending.
And thanks for attending on my behalf. Well, if you have any further questions, you can email Vlado or me, and I'll forward them to Vlado. And yeah, with this, I just wanted to thank you again for staying until the end. You will receive a follow-up with all the information, the recording, the slides, and the long report Vlado mentioned in the beginning. And yeah, hopefully you learned something today. Thanks, and bye.